Hello, in this lecture we will find the value of 2 times AP, or the size of 2 times AP. Actually, we have, you can see in the picture, we have a triangle ABC in the picture with side AC equals to 70 units, side BC equals to 50 units, and side AB of the triangle equals to 90 units. We also have a circle. The center of the circle is in point P, and point P is actually on side AB of the triangle, and also side AC of the triangle is tangent to the circle at point, we will call that point O. Again, side AC of the triangle is tangent to the circle at point O, and also side CB of the circle is tangent to the circle at point, we will call that point E. Okay, again, side CB of the circle is tangent to the side CB of the triangle is tangent to the circle at point E, and side AC of the triangle is tangent to the circle at point O. Okay, now we will connect points C and P together by a straight line. And we will also connect points P and O by a straight line. As you can see in the picture, PO is also the radius of the circle, because it starts from point P, the center of the circle, and ends on point O on the circle. So it is defined as the radius of the circle. We will mark it as R. And we will also connect points P and E together by a straight line. And PE is also the radius of the circle. I will mark it as R, abbreviation of radius. For the same reason, P is the radius of the circle, because it starts from the center of the circle. The line starts from the center of the circle and ends on the circle, on point O of the on point E of the circle. So PE is the radius of the circle. Okay, so PE and PO are the radiuses of the circle. Okay, so actually we have a rule that if you have a circle and from an external point of the circle, let's call that point V, and actually V is external point of the circle because point V is not inside the circle nor on the circle, but it is outside the circle. For that reason, point V is external point of this circle. So if from point V we will draw two tangents to this circle, let's draw the first tangent to this circle. So this is the first tangent of the circle. Let's call the touching point between the tangent and the circle L, and then we will draw the second tangent to this circle. Let's call the touching point of the tangent with the circle F. So according to the rule, VF equals to VL. Actually, VF is not in the picture. It is not seems like a tangent, but okay, we can draw it again because it relates to tangent to the circle. So if we have a circle and from external point of that circle we draw two tangents to the circle, if from point V we draw two tangents to the circle, then we can say that VF equals to VL. Okay, because if you draw from external point of a circle two tangents to the circle, then those two tangents are equal to each other. Okay, so VF is equal to VL. Okay, actually we can implement this rule in our specific circle, because actually we have point C that is external point of this circle. It is external point because it is not in the circle nor on the circle, so it is considered as external point to the circle. And from point C we have two tangents to the circle. The first tangent to the circle is tangent CO, and the second tangent to the circle is tangent CE. So according to the rule, we can say that CO is equal to CE. Okay? according to the rule that I mentioned, CO equals to CE. This tangent is equal to this tangent. Okay? And as I have already told you, also PE equals to PO, because they are both the radiuses of the circle. So we can write down that PE is equal to PO and both equals to R. Okay? And also PC equals to itself, so we can write down that PC equals to PC. And actually we can say that three sides of the green triangle are equal to three sides of the black triangle. Three sides of the green triangle are equal to three sides of the black triangle. Why? Because CO, side CO of the green triangle is equal to side CE in the black triangle. And side PO in the green triangle is equal to side PE in the black triangle. They are both the radiuses of the circle. So they are equal to each other, and PC, side CP or PC or CP, it is the same. Side CP in the green triangle is equal to side CP in the black triangle. Okay, for that reason, actually side PC or CP is a common side, because it belongs to the green triangle and it is also belongs to the black triangle. Okay, so we can say that three sides of the green triangle are equal to three sides of the black triangle, and for that reason we can deduce that the green triangle is congruent to the black triangle. Okay, we can deduce that triangle COP congruent to triangle CEP. Okay? Okay, because of the fact that three sides of the green triangle are equal to three sides of the black triangle, we can deduce that the green triangle is congruent to the black triangle, or triangle COP, that is the green triangle, is congruent to triangle CEP, that is the black triangle. Okay? So, and also because those two triangles are congruent to each other, we can also deduce that angle OCP, this angle OCP in the green triangle equals to angle ECP in the black triangle. Okay, again, angle OCP in the green triangle is equal to angle ECP in the black triangle. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, I will write it down. Corresponding angles in congruent triangles are equal to each other. Again, congruent angles, that is to say angle OCP and angle ECP, congruent angles in corresponding angles, corresponding angles. Angle OCP corresponds to angle ECP, so corresponding angles in congruent triangles, the green triangle congruent to the black triangle, so for that reason those corresponding angles are equal to each other. So angle OCP in the green triangle is equal to angle ECP in the black triangle. Okay, so if we call to angle OCP theta, then angle ECP will be also theta because those angles equal to each other. Okay, so I can write it down. Angle OCP equals to theta and also equals to angle ECP that also equals to theta. Okay, we defined that angle OCP will be equal to theta, so angle ECP also will be equal to theta because those two angles are equal to each other. Okay, now I will draw triangle ABC again. So I drew triangle ABC again. As you can see, AB equals to 90 units, AC equals to 70 units, and side CB equals to 50 units. And we also have P is the center of the circle, and actually here we have angle theta, and here also is angle theta, because those two angles are equal to each other. So actually, if you look at angle ACB, then you can say that PC splits angle ACB to two halves. This is the first half and this is the second half. For that reason we can define CP as angle bisector. Okay? So CP is angle bisector. Again, because of the fact that line CP splits angle ACP to two halves, this is the first half and this is the second half, we can define line CP as angle bisector. Okay, so according to angle bisector theorem, angle bisector theorem okay, angle bisector theorem. Actually, the theorem states that an angle bisector in a triangle divides the side that it hits in a ratio that equals to the ratio of the angles sides. I will read again the angle bisector theorem and then I will explain it in detail. Angle bisector theorem states that an angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angle's sides. Okay, now I will explain the theorem. An angle bisector actually we relate to CP because CP, I have already explained to you that CP is angle bisector because it divides angle ACB to two halves. So an angle bisector CP in triangle ABC divides the side that it eats in a ratio. So as you can see, CP eats side AB of the triangle and it eats side AB on point P and it divides it to two parts, part AP and part PB. So the ratio between those two parts are AP over PB. So we can write that the ratio between the parts that is AP over PB, the ratio between the parts that angle bisector CP creates is AP over PB, and that ratio equals to the ratio of the angle's sides. So AP over PB equals to the ratio of the angle's sides. When we say angle, we relate to the angle that is divided to two halves in triangle ABC, and the angle that is divided to two halves in triangle ABC is angle ACB. Angle ACB is divided to two halves. Theta is the first half and this theta is the second half. So angle ACB is divided to two halves. So the ratio of angle ACB sides, actually angle ACB consists of two sides, side AC and side CB. So the ratio between the sides of ACB equals to AC over CB. Okay, AC over CB. Okay. So AP over PB equals to AC over CB. Now I will repeat it again and explain the theorem. Angle bisector theorem states that an angle bisector, that is to say CP, in triangle ABC divides the side that it eats, that is to say CP eats AB, side AB, it divides it to two parts, part AP and part PB, and the ratio between those two sides is AP over PB, AP over PB, and that ratio is equals to the ratio of the angle's sides. As I have already told you, we relate to angle ACB that is divided to 2 halves by CP. So it equals to the ratio of the angle sides. And the sides of ACB is AC over CB. And the ratio between those sides is AC over CB. So AC over CB equals to the ratio that CP divides side AB. That is to say AP over PB. Okay, so again, an angle bisector CP in triangle ABC divides the side that it hits, so divides side AB in 2 parts, part AP and part PB, and the ratio between those 2 sides, that is to say AP over BP, equals to the ratio of the angle sides. And the angle sides, the ratio of the angle sides is AC over CB. So it is equals to the ratio of AC over CB. Okay? As I've already told you, we relate to the angle that is divided to 2 halves. That is to say angle ACB. And angle ACB consists of 2 sides, side AC and side CB. And the ratio between those 2 sides is AC over CB. So that ratio AC over CB equals to the ratio that CP divides side AB. That is to say AP over BP or AP over PB. Okay? So I will explain again. An angle bisector CP in triangle ABC divides the side that it hits, that is to say divides side AB of the triangle in a ratio actually CP, the angle bisector, divides side AB of the triangle to 2 parts, to part AP and part PB, and the ratio between those 2 sides, that is to say AP over PB, equals to the ratio of the angle's sides. And the ratio of the angle's sides, that is to say, equals to AC over CB. So AP over PB equals to AC over CB. That is the ratio of the angle's sides. Okay, so the ratio that CP divides AB, that is to say AP over PB, equals to the ratio of the angle's sides. That is to say AC over CB. Okay, so I'll write this equation again. I will mark it as equation 1. AP over PB equals to AC over CB. Okay, this is the equation of the theorem. AP over PB equals to AC over CB. Okay, so here we will define that AP equals to X. Okay, AP equals to X. And actually, as you can see, PB will be equal to AB minus AP. Okay, AB minus AP equals to PB. Very simple. Yes, so actually PB will be equal to AB, that is 90, minus AP, that is X. So AP equals to 90 minus X. Okay, PB equals to 90 minus X. Okay, 90 minus X. Okay, so actually I write it here, AP equals to X and PB equals to 90 minus X. Okay, so I wrote it here, AP equals to X and PB equals to 90 minus X. So actually in equation 1 we can substitute AP by X because AP equals to X, and PB by 90 minus X because PB equals to 90 minus X. Okay, so we'll do it now. Instead of AP I will write X, and instead of PB I will write 90 minus X equals to AC over CB. Okay, here I substituted X, AP by X because AP equals to X, and PB by 90 minus X because PB equals to 90 minus X. And as you can see here, AC equals to 70 and CB equals to 50. So we can substitute AC by 70 and CB by 50. I write first of all that AC equals to 70 and CB equals to 50. So we write that X over 90 minus X equals to AC. Instead of AC I can write 70, and I can substitute CB by 50 because CB equals to 50. Again, X over 90 minus X equals to AC. AC equals to 70, so we can substitute AC by 70 over CB. CB equals to 50, so we can substitute CB by 50. Now 70 equals to 7 times 10 and 50 equals to 5 times 10, so I can write it here. Okay, 70 equals to 7 times 10 and 50 equals to 5 times 10. So we can substitute 70 by 7 times 10 and 50 by 5 times 10. So I will do it now. So here I substituted 70 by 7 times 10 and 50 by 5 times 10. Actually here we have 10 in the numerator and we have also 10 in the denominator, so we can cancel 10 because we have 10 in the numerator and in the denominator, or we can reduce the equation, this side of the equation, by 10 because we have 10 both in the numerator and in the denominator. Okay, so we will get that x over 90 minus 6 equals to 7 over 5. Okay, x minus 90 minus 6 equals to 7 over 5 because we cancel 10. So here we can multiply both sides of the equation by 5. X over 90 minus 6 equals to so we multiplied both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5 times over 90 minus 6. Now we'll multiply both sides of the equation by 90 minus 6. Actually, we can do it because, as you can see in the picture, x is less than 90 units because AB equals to 90 units and x, that is AP, is less than 90 units. So 90 minus x will be a positive number. So 90 minus 6 can never be 0. For that reason, it is allowable to multiply the equation by 90 minus 6. Okay? We'll get that 5x equals to 7 times. So after we multiplied both sides of the equation by 90 minus 6, we got that 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. Now we will open the brackets in this side of the equation. Five x equals to 600. So we open the brackets. 5x equals to 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Now we can add, we will add 7x for both sides of the equation. We get so here we added 7x to both sides of the equation, so 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. So 12x divided by 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. Okay, but we actually know that we actually defined that x is equal to AP. Yes, we defined x that equal to AP. AP equals to x. Okay, that how we define x, that x equals to AP. Okay, I'll write it here. According to our definition, x equals to AP, so 2 times 6 will be equal to 2 times AP. Okay? Okay? If x equals to AP, 2 times 6 will be equal to 2 times AP. Now we have in equation 1 that 2 times 6 equals to 105, but 2 times 6 equals also to 2 times AP, so we can add to equation 1 that 2 times 6 equals to 2 times AP according to this equation. Okay? Okay, 2 times 6 equals to 105, but 2 times x also equals to 2 times AP, so we can add that 2 times 6 also equals to 2 times AP. So here we have the equality that states that 2 times AP equals to 105. Okay, we have the equality that 2 times AP equals to 105, so we can write it down. Or it is actually 2 times x equals to 105 units. The units might be in millimeters because 105 millimeters is equals to 10.5 centimeters, so it makes sense that it is 105 millimeters. Okay, so the answer to our question is that 2 times 6 also equals to 2 times AP, so actually we got the equation that 2 times AP equals to 105 units. As I've already told you, it might be, the units might be millimeters. It is actually 10.5 centimeters. It is impossible that it is in meters, because if 2 times AP equals to 105 meters, it cannot fit over even the room. It is bigger than the room itself, so it is impossible. So the answer to our question is that the 2 times AP equals to 105 units. Okay, so 2 times AP, this straight line, equals to 105 units. Okay, now I will summarize the lecture. Actually, we wanted to find the value of 2 times AP, and we have a triangle that we know the sides of the triangle. AB equals to 90 units, AC equals to 70 units, and BC equals to 50 units. And we have also a circle that the center of this circle is point P, and point P is on side AB of the triangle. Okay, so we have, and also we know that side AC of the triangle is tangent to the circle at point O, and side CB of the triangle is also tangent to the circle at point E. So, according to the rule that if from external point of a circle you draw two tangents to that circle, then those two tangents are equal to each other. For that reason, VL is equal to VF. So we can implement this rule in our circle, and we can say that CO, that is a tangent to the circle, is equal to CE, that is also a tangent to this circle, because actually those two tangents to this circle are from point exit, from point C, that is external point of the circle. For that reason, we can say that CO, those tangents are equal to each other. That is to say, CO equals to CE. And C is, of course, an external point of this circle, because CE is not in the circle, nor on the circle. So it is outside the circle. For that reason, C is external point of this circle. And according to the rule that I said, CO equals to CE, and also PE equals to PO, because both are radiuses of this circle, they are equal to each other, and also PC equals to PC. For that reason, actually, three sides of the green triangle are equal to three sides of the black triangle. And for that reason, we can deduce that the green triangle is congruent to the black triangle, or the green triangle overlaps the black triangle. And for that, we can deduce from it that angle OCP of the green triangle is equal to angle ECP. Again, angle PCO of the green triangle is equal to angle ECP of the black triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. For that reason, this angle equals to this angle, or angle OCP in the green triangle is equal to angle PCE in the black triangle. Okay, so if we call to angle OCP theta, angle ECP will be also theta, because those angles are equal to each other. So I draw triangle ABC again, and as you can see, AC is 70 units, BC is 50 units, and AB, side AB of the triangle ABC is 90 units. And actually CP is the center of the circle, and line CP will be the angle bisector because it divides angle ACB of the triangle to two halves. This is the first half and this is the second half. For that reason, CP is angle bisector in triangle ABC. Okay, so, and according to angle bisector theorem, an angle bisector, that is to say P or CP, in triangle ABC divides the side that it hits, divides side AB to two parts, parts AP and the other part is part PB, and the ratio between those two parts, that is to say AP over PB, equals to the ratio of the angle's sides. We relate to the angle that is divided to two halves, that is to say to angle ACB, and angle ACB consists of two parts, part AC and part CB, and the ratio between those two parts is AC over CB. So AC over CB, this ratio equals to the ratio that CP divides side AB of the triangle, and the ratio that side AB divides side AB of the triangle equals to AP over PB. That ratio equals to the ratio of the angle sides, that is to say AC over CB. Okay, we know that we defined AP as x, AP equals to x, so PB will be equal to 90 minus x because PB equals to AB minus AP, so it is 90 minus x. And we know that AC equals to 70 and CB equals to 50, so we can substitute AP by x, PB by 90 minus x, AC by 70 and CB by 50. And after we solve this equation, that is only one equation in one variable, that is x, we have only one variable, that is variable x, we actually got to the result that 2 times x, that is to say it is 2 times AP, because x equals to AP, so 2 times x is 2 times AP. 2 times x equals to 2 times AP equals to 105 units. Okay, 2 times AP equals to 105 units, so 2 times AP equals to 105 units, and that is the answer to the question. The value of 2 times AP equals to 105 units. As I already told you, it might be the units might be millimeters, because 105 millimeters is about exactly 10.5 centimeter. But according to the picture, it is even less than. Okay, it might be that it is millimeters, because if it is 2 times AP, then it actually might be really 10.5 centimeters. Okay, so that is the answer to the question, that 2 times AP equals to 105 units. Okay, thank you very much.